Good morning, everyone, and welcome to an edition of Sci Friday. I have something cool here that I want to show you. So the video you see to your right and my left is one that I took during the Afterparty dance last Friday after the football game. Notice how the strobe mounted on the floor is changing colors, as is the S in Indians. Depending on the color of the strobe, the color of the interior of the S appears to shift between red and black. Although you do see a little bit of the color of the strobe due to the wall padding not being entirely matte. So for reference, this is what the S looks like under normal light. I produced this photograph using the flash on my phone camera. You can see that the outline is white and the interior is red. Let's take a look at what the interior looks like under each of the 7 colors that the strobe was capable of producing. First, the primary colors. Under green, the interior was black. Under blue, the interior was black. Under red, the interior was red. Now, some of you might be screaming, "Green isn't a primary color. I learned in elementary school that it is a secondary color." Now, there are 2 models of color, of the way color combines. One is called subtractive color theory. Subtractive color theory explains how inks and dyes combine, such as in paint. This is the theory you probably learned in preschool or kindergarten because that what was most relevant to you at the time. You were probably doing things like mixing paints together. Additive color theory explains how the colors of light work. Additive color theory explains the colors of the pixels on the screen you're watching this video on. In additive color theory, green is a primary color, along with blue and red. Cyan, yellow, and magenta are secondary colors in additive color theory. Now, let's look at the secondary colors. So, under cyan, the interior was black. Under yellow, the interior was red. Under magenta, the interior was red. Let's talk about why this happens. An object that is red because it is reflecting red light. If there is no red light being directed at it, there is no red light to reflect, so an object will appear black. Both yellow and magenta light contain red light. Yellow light contains green and red light. Magenta light contains blue and red. So the red S looks red under yellow and magenta light. Cyan light, on the other hand, is made of blue and green. So the red S appears black. And then, of course, when the light was green or blue, the S appeared to be black. When the light is red, the S appears to be red. Now, let's look at the S when the strobe is flashing white. Of course, white light contains all 3 primary colors of light, so the interior of the S appears red. Alright, everyone. Well, now you know how to excite your friends with physics the next time you are at a dance or party that uses lights that strobe different colors. We hope you like what you saw here. Have a great weekend, everyone.